Find the slope of the tangent line to the curve, 2 sine of x, cosine of y, 5 of those, minus 5 sine of x, cosine of y plus x equals 6 pi. We have this at 0.6 pi and 3 pi over 2. Okay, so what we're going to do is we're going to take the derivative of everything here. We're going to choose x, could do y. X is more traditional, and it's kind of good to kind of get a pattern for how you do these. So taking the derivative of 2 sine of x with respect to 2 sine of x with respect to x, we get 2 cosine of x. Then we multiply by the derivative interior, which is derivative of x with respect to x, which is 1. So I'm going to leave that off. Plus 5. Derivative of cosine of y will be sine of y, negative sine of y, and we'll take the derivative of y with respect to x. So the idea here is we took the derivative of the interior was y, derivative of y with respect to x is dy dx. So now we're going to do the product rule here, leave the negative 5 on the outside there. I'm going to start by saying sine of x is the one I don't take the derivative of. Then I'm going to multiply by the derivative of cosine of y, which we know from before is sine of y. Then it'll be a negative. And then we're going to have a dy dx. And then we're going to add to that the derivative of sine of x, which is cosine of x, multiplied by cosine of y. Cosine of y. And we leave the cosine of y alone. And then we don't multiply really by we do multiply by the derivative of the interior for the sine of x, but derivative of x with respect to x is 1. Okay, then we need to take the derivative of that guy, plus 1, derivative of x with respect to x. And that will equal 0. You can see this is pretty long at this point, so we're going to try and simplify things, combine terms as much as possible. So, first I'm just going to write everything out, clean it up a little bit, hopefully. 2 cosine of x minus 5 sine of y dy dx. That's important. I guess everything is important, but feels more important. We have plus 5. Then we do, wait a sec, sine of x, sine of y, sine of x, sine of y. The negative is already taken care of. Then we still have a dy dx there, also important. And then I'm going to do minus 5, because I distribute the 5, cosine of x, cosine of y, plus 1, still equals 0. Okay, so now I'm going to put all the dy dx's on one side, and all the non-dy dx's on the other side. So I'm going to leave the 2 cosine of x over there, because he looks comfortable. Skip that one for now. Skip that one for now as well, because it also has dy dx, which leaves me to the negative 5 cosine of x, cosine of y, it's like cosine of y, plus 1 equals, and this side will be dy dx, multiplied by the quantity. So we have a negative 5 sine of y, plus 5 sine of x, move over just a little bit, sine of y. Now here I'm just going to count terms, make sure I didn't lose too many of them. So let's see, we have 1, 2, 3, 4, 5. Here we have 1, 2, 3, 4, 5. Yep, seems reasonable enough. So now we can solve for dy dx, which will be the slope of our tangent line. Dy dx equals 2 cosine of x minus 5 cosine of x cosine of y. I should really write my x's differently so that I don't get the y's and x's confused. That is going to be a human performance trap of epic proportions. Then we'll do a 5 times quantity sine of x. There we go. I like that. Sine of y minus sine of y. And I already took care of the 5 on the other side over there. So now we got our dy dx, and we have a point 6 pi and 3 pi over 2. 6 pi and 3 pi over 2 at 6 pi, 3 pi over 2. I'm going to assume that the 6 pi is x and 3 pi over 2 is the y. I guess if I was motivated in life, I could plug one of these in and make sure it actually works. Can I do that? Okay, so if I do 6 pi, so I plug in, no, because I have to, that could be a pain. Yeah, I don't gotta do that. Ooh, could I? Maybe. I don't know. Not going to. I'm going to assume that the equation they actually gave us, I'm going to assume that the point they gave us is actually on the graph that they gave us. If I had more time and I was a better person, I would check. Alas, I am not. Okay, 6 pi, so we're going to find our slope here. So we have, Okay, so 2 cosine of 6 pi minus 5 cosine 6 pi cosine 3 pi over 2 plus 1 all over 5. Move down, try and get everything in frame. Sine 6 pi times sine 3 pi over 2. This is looking tragic. Minus sine of 3 pi over 2. Hop, hop. Canceling color. I know I should have gotten something darker. Close the bracket. Okay, so cosine of 2 pi is the same as cosine of 0, and 4 pi and 6 pi, which is 1. So that's good. Cosine of 6 pi still is 1, but cosine of 3 pi over 2, that's the same as cosine of 270 degrees, which is 0, which means this whole portion goes away. We're left with 1. This part, sine of 6 pi, is going to be 0. This one will be 1, but it doesn't matter because it's multiplied by 0. And sine of 3 pi over 2 will be negative 1. And so we're left with 2 times 1 plus 1 all over 5 times negative 1, which is 1. Did I do that right? So much math. So I'm going to say that we have 3/5 is our slope, m, if you will. So now, scroll over here. I know I'm way off the reservation at this point. Y minus y1 equals mx minus x1. So that is the general formula for a line. And so, or how to get it from based on 2 points in a slope. I'm going to move this over here. Feeling cramped. I'm going to straighten it out a little bit. There we go. I know I didn't move it much, but it makes my fields feel better. Nope, don't want green. Want better contrast. Purple. So we have y minus, all right, don't mess this up, 3 pi over 2. 3 pi over 2 equals 3/5 times x minus 6 pi. 6 pi. P pi. Y equals, I wonder why. You think pi would, pi? Feels like it, Probably not pronounced p. Is it pronounced p in other languages? Maybe. Maybe French. Maybe French say p. That'd be funny. 3/5 x minus 3 times 6 over 5 pi plus 3 pi over 2 equals 3/5 x minus, all right, common denominator, multiply this by 2, 10, 2, multiply this by 5 over 5, which makes that 10. So we have 15 pi minus 2 times 3 is 6. 6 times 6 is 36. So plus over 10, put a pi there. 15 and 36, that's 15 plus 6, that's probably 21. So equals 3/5 x, y equals 3/5 x plus minus 21 pi over 10. Maybe. Bump. See what we got here is a question. Find the slope. Oh, I didn't have to find the line. I just had to find the slope. 3. Answer there is 3/5. 3/5. M. Right there. Found it. 3/5. The first thing I circled. Gosh darn dang it. Found the whole gosh darn tangent line. So that is how you find it using implicit differentiation. Take the derivative of everything with respect to whatever you'd like. They mean the slope. They probably mean rise over run. So you want to take dy dx. That gives you m. Plug in your numbers. Get the answer. Hope that helped. See you next time.